called? Let's see. And orthocenter. Go. Alright, this is card number 37, where we're going to talk about the first of the locus theorems. Okay, the locus of points. At a fixed distance D from point P is a circle with the given point P as its center and D as its radius. Okay, let's turn this over and draw a picture of what that looks like. Alright, so I'm going to make a dot right about in the middle here, and I'm going to make a circle using my compass. Now I'm going to draw this very lightly because I'm going to have to erase part of it. Alright, because what it wants us to do is it wants us to dash the lines. Because when we talk about locus, what we do is we draw the locus using dashed or dotted lines. Okay? And the center is point, let me just make sure I got this right way. The center is point P. Alright, and this distance from the center to the edge, they've called it D, but we know that P is the center of the circle and D is the radius of the circle. Alright, so that's the first locus theorem. Now we'll do card 38. Just give me 1 second. Okay. The locus of points at a fixed distance which again we'll call D, from a line and we'll call this line L, is a pair of parallel lines D distance from L, and on either side of L. Okay, let's see what this looks like. Alright, what you have is a line. Okay. And this is our line L. So we'll label this line L. And the locus of points is a fixed distance, and we draw these dashed. Okay. So these two lines, which represent the locus of points at a fixed distance from line L, these are both the same distance. Okay? So this distance right here from here to here is D, and the distance to this bottom line is also D. So they're both the same distance away from line L. Okay? Now that's card 38, so we're on card 39, which is the third locus theorem. Okay, the locus of points equidistant from 2 points P and Q is the perpendicular bisector of the line segment determined by the 2 points. And here's what that means in a picture. Okay, say we have this line segment and it's PQ. The locus of points equidistant from those 2 points, I went halfway, and I also have to go, it's a perpendicular bisector, so I also need to go perpendicular. Okay. Those are all the points on that dotted line are the same distance from P and Q. They're equidistant from P and Q. That's locus theorem. That's the third locus theorem. So now we're on the fourth locus theorem, which is card 40. The locus of points equidistant from two parallel lines and we'll call those lines L1 and L2 is a line parallel to both L1 and L2 and midway between them. Okay. So if I draw my two given lines, L1 and L2, one of them here, and one of them here. So let's say that this was L1 and this is L2, right? So the locus of points equidistant from those two lines is a line directly in between them. So let me draw that line. This is 1 1/4, so I gotta go 1/2 inch plus 1/8 inch. And the same deal over here. That's where my dotted line's gonna go. Okay, and we'll put arrows on the end to show that that goes on forever. And that is the fourth locus. And we have one more locus problem. This would be card 41. This is our fifth and final locus theorem. And it says the locus of points equidistant from two intersecting lines L1, and we'll call them L1 and L2 again. Those will be our two lines. Is a pair of bisectors that bisect the angles formed by L1 and L2. Okay, let's draw a picture of that. So here's what we have going on. I'm going to draw two lines these are going to be my L1 and L2 lines. Okay, these are my two intersecting lines, and we'll call this one L1 and this one L2. Now the locus of points equidistant from those two lines would be all those points that bisect those two angles and all the points that bisect these two angles as well. Okay? That's the locus of points equidistant from two intersecting lines. It's all the points in the middle of the angles. Okay? And that is the end of the locus theorems. Alright, so now we're going to talk about what we need to remember for logic and negations of statements and things like that. So this is card 42. So in logic, comma, the negation of a statement can usually be formed by placing the word not into the original statement. Okay? Under negation, comma, what was true will become false or what was false will become true. Okay? And let's do a simple example. So let's say we had the original statement a dog is a cat. And this is obviously false. So then to do the negation, we could just say a dog is not a cat, which then the truth value changes from false to true. Okay? That's good enough for negation. Now, let's take out the next index card. And this is another part of logic. This is card 43. And it's conjunction. So in logic, a conjunction is a compound sentence formed by combining two sentences and then in parentheses let's put or facts using the word and. Okay? A conjunction is true only when both sentences and in parentheses or facts are true. Okay, let's turn this over and look at an example. So let's say blue is a color and 7 plus 3 equals 10. So true, right? The first part is true and the second part is true. So when they're both true, true and true equals true. Alright? Another example could be 1 hour is exactly 55 minutes and 1 minute is 60 seconds. Well, we know this part is false and this part is true. So F and T is false. Since they're both not true, the whole statement is false. Okay? Let's think here. I guess we'll try to fit two more. So let's draw a line separating these. This is example 1. This is example 2. Let me just divide up this. This box first so I don't run out of room. So let's say the third example said something like blue is a color and 7 plus 3 equals 11. This first part, blue is a color, is true, but the second part is false. So when you have T and F, again you get false because they both have to be true. So we can do one more type of an example where they're both false. Like 1 hour is 40 minutes and 7 plus 3 equals 11. The first part is false and the second part is also false. So when you have F and F, what you get is F. So there's essentially 4 situations. The only one that's true is when they're both true for a conjunction. Okay? That was card 43, so now we're on card 44, and we're going to talk about a disjunction. Okay? So in logic, a disjunction is a compound sentence formed by combining two sentences or facts using the word or. So for a conjunction, we had the word and connecting the sentences. For a disjunction, the word or. So a disjunction is true when either or both sentences or facts are true. So let's see our examples of this. Let me just divide this up ahead of time. So 2.5, 5, 7.5. So I'm dividing this into 4 equal sections because there's 4 examples. So 2.5, 5, 7.5. Okay. So for example 1, blue is a color, or 7 plus 3 equals 10. And we know the first part is true and the second part is true. So when we have a T or a T, it's true because at least one of them is true. So now the second one could say 1 hour is 55 minutes, or 1 minute is 60 seconds. The first part is false and the second part is true. So when we have an F or a T, that's true. Okay, that's different from the conjunction. So if we have at least one true, then the whole thing is true. When we have a disjunction, an or statement. So for the third example, 3 plus 4, now let's say the word cat has 3 letters, or 7 plus 3 equals 11. So the word cat has 3 letters is true. 7 plus 3 equals 11 is false. But when we have a disjunction or an or statement, if we have at least one T, the whole thing is true. So finally, we can do one more example. Let's say 3 plus 4 equals 6, or all dogs meow. Well, we know 3 plus 4 equals 6 is false, and we know all dogs meow is false. So the only time an or is false is when both are false. Okay? So that was card 44. We're on card 45. Let's see what we have next. Alright, we're talking about conditional now. So in logic, a conditional is a compound sentence formed by by combining two sentences or facts using the words if dot dot dot. So if something, then something else dot dot dot. Okay? Let's see. This can also be said as the if implies the then. All right. A conditional is only false when true implies false. And remember, the true is the first part is the if part, and the second part is the then part. Okay? So only when the if part is true and the then part is false will the conditional be false. All right? Let's see if we can get some examples here. Okay. So I really need to divide this now into 5 sections. So we'll go by 2. 2, 4, 6, 8. 2, 4, 6, 8. So we need to divide this into 5 sections because there's an original statement, and then there is well, let me think about this. Okay, we actually can do it into 4. I'd rather do it by 4s. So if the card is 4 inches, because it's a 4 by 6, it would be every inch. Okay. So, for the first one, let's say it said if blue is a color, then 7 plus 3 equals 10. The first part is true, and the second part is true. So when T implies T, it's true. Okay? So for the second one, we could say if blue is a color, then 7 plus 3 equals 11. Now the first part is true, but the second part is false. And this is the only time, so when T implies F, it's false. So when the first one is true and the second one is false, the conditional is false. So for the third example, we could say if 7 plus 3 equals 11, then blue is a color. Now this may seem confusing. If 7 plus 3 equals 11 is false, then blue as a color is true. Now in this case, when false implies true, it's actually true. The conditional is considered true. Okay? And for the fourth one, if we said if 7 plus 3 equals 11, then 1 hour is 55 minutes. So the first part is false, and the second part is also false. And even in this case, when F implies F, it's considered true. Okay? The only time a conditional is false is when T implies F, when the if part is true and the then part is false. Okay? That is card 45. Okay, let's see what's next. In logic, a biconditional is a compound statement formed by combining two conditionals under N. And using if and only if. Biconditionals are true when both statements, we could say or facts, have the same truth value. In parentheses put when both are true or when both are false. Let's see what that looks like. Okay. We only need, well, actually we need to do 4 again. Just check one thing. Okay. So we got, I'm dividing this thing into the same 4 sections so we can identify the 4 different types of examples. Okay. So, for example 1, we could say blue is a color if and only if 7 plus 3 equals 10. So the blue is a color part is true, and the 7 plus 3 is true. So let me just see something. So when T, if and only if T, that is true because they're both the same, right? So for the second one, let's say 7 plus 3 is 11. If and only if blue is a color. So the first part is false and the second part is true. So if we have F, if and only if T, well then since they're both different, this is false, because for a biconditional they have to be the same for it to be true. So for the third one, if we had blue as a color, if and only if 7 plus 3 equals 11, we know blue as a color is true, and 7 plus 3 is 11 is false. So when we have T if and only if. True if and only if false is going to again be false because they're not both the same. And then finally we could have all dogs meow if and only if 7 plus 3 equals 11. We know both of these are false. So when you have false if and only if false, then since they're both the same, they're both false, this is actually true. Alright, so that's the information you need to know for a biconditional. Now I just want to go back. Oh, this is card 46. And I just want to go back to card 42 for a second, where we talk about negation. I want to give you one more example of negation. Okay? Alright. So I'm just going to divide this side in half. So this was example 1, and for example 2, suppose the original already had a not in it. Like a dog is not a cat. And we know that is true. So if we wanted to write the negation, we know that we insert the word not. So that means we could put a dog is not a cat, and that would change the negation. That would change the truth value of the original to false. But that's not good English. All right, so a better negation would just to put a dog is a cat, which is still false. And what happens here is that two nots cancel each other out. So watch out for this one in on a Regents question, because they like to do that. All right, so if the not is already in the original, just take it out, okay? Because we don't use this not type of English. All right, we cancel out two nots, just like we cancel out two negatives to become a positive. Okay, so that's 42, 43, 44, 45, and 46. So the next thing we have to talk about, okay, is, let's see, what is the next thing we have to talk about? We're going to talk about the converse, the inverse, and the contrapositive. Okay? All right, before we go on with the next card, I want to go back to card 17. Okay, and I want to erase a couple of things. I want to erase these 3 lines. They're not appropriate for this card. They should be on a different card. So let's go ahead and erase these 3 statements. We're going to put them on another card when we actually talk about circles. But they shouldn't be on this card, so let's go ahead and get rid of those. And we're going to add something also on here. What I do want to write is let's erase this formula. And let's put the formula nice and big, skip a line. L equals 2 pi RH. And in parentheses off to the side, put remember the circumference of a circle is 2 pi r. Okay, and let's see. We can erase this diameter part down here and this radius part right here, and let's put, actually let's just erase those. And let's put L lateral area, H is height slash altitude, and R is radius. Okay, so we fixed card 17 to where it should be. And now I also want you to go to card 45, and we're going to just we're going to add something. Put the if part is called the hypothesis, and the then part is called the conclusion. Okay, so just add that to card 45 when we're talking about conditional statements. Alright, so let's see now. We're on card 47. Let me just double check to make sure we're on 47 here. Yes, okay, so 47 we're going to start talking about what's called the converse, the inverse, and the contrapositive, and it has to do with conditionals. So here's what we're going to write. The converse of a conditional statement is formed by switching the hypothesis and in parentheses let's put if part so by switching the hypothesis and the conclusion, which is the then part. Okay? Let me just see something. Let's put the converse has the same truth value as the inverse of the original statement. And we'll talk about inverse next. They are what's called logically equivalent. The converse may or may not have the same truth value as the original statement. Okay? And let's see an example of this on the back. Okay. So here's an example. All right, here's our conditional statement. This is the original. All right. If the space shuttle was launched okay, then a cloud of smoke was seen. So then the converse of this statement would be if a cloud of smoke was seen, comma, then the space shuttle was launched. Okay? And that's it for converse. So I'm going to take out another card, and we're going to talk about inverse. Okay, and this is card 48. The inverse of a conditional statement is formed by negating the hypothesis remember, that's the if part, and negating the conclusion, which remember is the then part. Period. Let's see. The inverse has the same truth value as the converse of the original statement. They are logically equivalent. The inverse may or may not have the same truth value as the original statement. Okay? Now, let's turn this over and do an example. Here's the conditional. If you grew up in Alaska, comma, then you have seen snow. The inverse would be, if you did not grow up in Alaska, comma, then you have not seen snow. You see how we just negated both parts by inserting the word not into both parts of the sentence. That's inverse. Okay? Let's sharpen this for a second. let's do the next card. Just card 49. And on this card we're going to talk about what's called the contrapositive. Okay. This is probably the most important one. The contrapositive of a conditional statement is formed by negating and switching. So we're going to do both. We're going to negate and switch the hypothesis, which is the if part, and the conclusion, which is the then part. All right? The contrapositive, this is a very important part right here. They always ask a question on this. The contrapositive has the same, let's erase this, always has the same truth value as the original conditional statement. Okay. All right. And they are logically equivalent. Let's turn this over and do an example. If 9, let's write down conditional. If 9 is an odd number, comma, then 9 is divisible by 2. That's the conditional statement. Now the contrapositive by the way, this is false, right? Okay. Because remember, when true, if the if part is true and the then part is false, then the statement is false. So the contrapositive will also be false. So what we would write is, if 9 is not divisible by 2, see, we're negating and switching. Then 9 is not an odd number. And this is also false. Alright? Let's put a little arrow here. Same truth value. Let's put always same truth value. Okay, so that is the 49th card. And that's pretty much, that's it for logic stuff.